Good evening and welcome again in this session. And in this session, we are going to actually we have a plan. We had a plan to figure out few questions, guiding questions on mathematics, and for that, I would like to welcome Professor Ghosh for mentoring the session. So I am handing over the session over to Professor C.K. Ghosh. Sir, this is now over to you.
Thank you, Anirban. In fact, I did not plan very systematically for this session, but then some guiding questions on mathematics was demand from some of the teachers. And it would be a mix of mathematics and physics and other miscellaneous areas. Uh, so let me make a beginning, and I'll request other teacher participants also to chip in whenever they feel like. Uh, Actually, I started on the other day, I was hinting at certain misconceptions, and which I feel that the students should be made aware of. Like the definition of angle, the very definition of angle. Now, we have studied that if two straight lines meet at a point, like what you see on the board, we get an angle. Now, what is this angle? Is this the space between? Is this the space between the two straight lines? Number one. And then, number two, is this definition of angle very much tenable? Suppose we want to make an assessment of the electrical consumption due to the rotation of a fan. And of the three blades of a fan, let this be one of the blades. It started rotating, and after several thousand rotations, it has come to this position, and the angle measures 50 degrees. It has come to this position, and the angle measures 50 degrees. So if you want to make an assessment of the electric consumption just by this angle, then a havoc will be created. You will not get the exact measure of the consumption because it has rotated several times and then it has come here. So is it not fair or is it not advisable to describe angle in terms of the rotation of a straight line? That is, a straight line is here. It rotates and takes up a position here. And what it describes is an angle. Now, this becomes all the more crucial when you go to define the trigonometrical ratios. The trigonometrical ratios, sine theta, cosine theta, tan theta, as when we had learned, were all described in terms of a right angle triangle. Say this angle is theta. We say that this is perpendicular, this is base, and this is hypotenuse. Now, fixing the hypotenuse is fine. The line, the straight line opposite to the right angle. This is the hypotenuse. But how can you fix the term perpendicular and base? Now, it's a very loose way of saying when you say sine theta is equal to perpendicular by hypotenuse or cosine theta is equal to base by hypotenuse. It's better to say sine theta is equal to opposite side by hypotenuse and cosine theta is equal to adjacent side by hypotenuse, because the word perpendicular is not a standalone word. We say perpendicular when two sides are perpendicular to each other. So I think you all agree that we should say cosine theta is equal to adjacent side by hypotenuse and sine theta is equal to opposite side by hypotenuse. And with this definition, we can carry along, say from 0 degree to 90 degree. But what happens with angles more than 90 degree? say 120 degree, 240 degree, 330 degree, 720 degree, 840 degree, and so on and so forth. But you ask the students to obtain the ratios of this angle, they will be able to determine the ratio using the formulas of what they call associated angle, or even say negative angle, cos of minus theta, sine of minus theta. So what is meant by these angles? So they are generally not aware of the generalized definition of sine, cosine, tan. So I say that you take a system of coordinate axes, the x-axis and the y-axis. This is the origin O. You take a straight line OA. The length of the straight line, say, is equal to L. And you rotate the straight line. Suppose it comes to this point. Now, this being a circle, the length of this straight line is also equal to L. And let the coordinates of the point be equal to xy. And the angle described is equal to theta. Then sine theta is equal to y by the length of the straight line. Cosine theta is equal to x divided by the length of the straight line. And tan theta is equal to y by x. And this takes us to the mnemonic all sine tan cos, which we ask the students to remember about the positivity of sine, cosine, and tan. Like when x and y are both positive, then sine theta, L is always positive. L being the length, it is always positive. Now, if x and y are both positive, then sine theta is positive, cosine theta is positive, and tan theta is positive, which happens in the first quadrant. If theta is such which brings the straight line to second quadrant, then here, now let me write as x1, y1, x2, y2. Now out of x2, y2, y2 is positive, x2 is negative. So cosine theta becomes negative, sine theta remains positive, and tan theta becomes negative. When you go to the third quadrant, left, this is the angle and the coordinates are x3, y3, then both are negative. And when both are negative, sine and cosine are negative, but tan is positive. And when you come here, then x is positive, y is negative. So cosine is positive, sine is negative. Cosine is positive and sine is negative. So that is the reason for saying all sine tan cos. That's how we arrive at the mnemonic all sine tan cos. And using this generalized definition, actually, if you attempt the derivation of the formulas which you learn through associated angles, like sine of 180 degree minus theta is equal to sine theta, sine of 90 degree plus theta is equal to cosine theta, sine of 270 degree plus theta is equal to minus cos theta, sine of 360 degree plus theta is equal to sine theta. All those definition which we arrive at, all the formula which we arrived at, can be obtained by using these definitions. So this generalized definition of sine theta, cosine theta, and tan theta, these are extremely crucial for the understanding of the formula of associated angle. So in this connection, I have two guiding questions. One is about that what should be the ideal definition of angle? Will it be the definition that when two straight lines meet at a point, then an angle is formed, or when a straight line describes an angle about a fixed origin, about a fixed pole, then an angle is described? So which one should be taken as the ideal definition of an angle? This is my first guiding question. My second guiding question is related to the maximum and minimum value of sine theta and cosine theta. Now, students know that maximum value of sine theta is equal to 1, cosine maximum value of cosine theta is equal to 1. Many of them say that the minimum values of these two ratios are equal to 0, which is, you definitely know, which is not true. The minimum value is equal to -1. So how do you arrive at that result? How do you arrive at this result in a very general way? If you say that if you plot a graph, well, definitely it oscillates between +1 and -1. So +1 is the maximum value, -1. But then you can argue that how long will you go on plotting the graph? Will there be some point where it shoots up beyond +1 or shoots down below -1? So I say that you start with this relation cosine square theta plus sine square theta is equal to 1, which is true for any value of theta. Cosine square theta plus sine square theta is equal to 1. Now, using this relation, you are finding that these are two variable quantities, but their sum is equal to a constant. These are two variable quantities, and their sum is a constant. So, when one is maximum, the other is minimum. The sum of two quantities is a constant. So, when one is maximum, the other is minimum. Therefore, the maximum value of cosine square theta corresponds to the minimum value of sine square theta, and vice versa. Maximum value of cosine square theta corresponds to the minimum value of sine square theta. And in order to know the minimum value of either sine square theta or cosine square theta, you don't need to fall back on trigonometry, because these are perfect squares. These are perfect squares, and the minimum value of a perfect square is equal to 0. Sine square theta being a perfect square, its minimum value is equal to 0. So the maximum value of cosine square theta is equal to +1. And therefore, c square is not greater than 1, or c square minus 1 is not greater than 0, or c plus 1 into c minus 1 is not positive. C square minus 1 is not greater than 0, so c plus 1 into c minus 1 is not positive. So I have to be a little measured about using the board. Say this is a number line, this is the point 0, and this is +1, and this is -1. So if c lies beyond +1, if c is more than +1, the first factor is positive, the second factor is also positive, and so the product is positive. So c cannot be more than +1, because this is something which we have established from a very fundamental relation. And if this gets violated, then the fact which violates this cannot be accepted. So c cannot be more than 1. If c is more than 1, then this is positive and this is positive, the product is positive. If c is less than -1, then this is negative, this is negative, the product is again positive. Only when if c lies between -1 and +1, then the product is negative. Or if c is exactly equal to +1, or if c is exactly equal to -1, then the product is equal to 0. Then also this is valid. So c lies between -1 and +1. So the minimum, and this I have done without using calculus. With the use of calculus, this becomes very simple. So the minimum and maximum value of cosine theta are -1 and +1, and like that, the minimum and maximum values of sine theta are -1 and +1, which can be proved without introducing calculus. So this is one particular proof which I wanted to show here, and this basically, in order to bring home the point that the maximum and minimum values of sine theta and cosine theta are +1 and -1. And we can ask this question. This can be a guiding question. Any one of that. What is the maximum value of sine theta? What is the minimum value of sine theta? But theta is a general angle, not acute angle, not restricted between 0 and 90 degrees. when theta is a generalized angle, what is the maximum value of sine theta? I'm talking from the point of view of the school students who have been introduced to trigonometry. This can be a guiding question, that what is the maximum value of sine theta, what is the minimum value of sine theta, what is the maximum value of cosine theta, what is the minimum value of cosine. And they will have to explain. They cannot just use their prior knowledge to say that the maximum value is 1 and the minimum value is -1. So these are two guiding questions, one regarding the definition of angle and another regarding the minimum and maximum value of cosine theta and sine theta. I thought that I would start with and like to have your reactions. May I have your reactions, please?
Professor Ghosh.
Hello. Sir Devmallo.
Yes, you continue.
Yes, yes, Mr. Shane, please tell me.
Sir, this is very nice presentation. And the question you asked, that is very valid, how you identify the perpendicular and the base. It's best way to deal with the opposite and adjacent. And sir, usually to my student, I use the formula SHOCATOA, SOHCAH and TOA. That is, sine is opposite by hypotenuse, cos is adjacent by hypotenuse, and tan is opposite by adjacent. I don't get into the terms of perpendicular and base. And
never get into perpendicular and base. Yes.
And usually when I start, I take the set square and keep them asking what is perpendicular and base. I keep it rotating. So they get confused every time because I'm keeping rotating. So then they come to the conclusion that there is no fixed perpendicular or base. It's depend how we look at the picture.
Right,
So
right.
Very important to introduce that concept to the children. And this I learned new from you, that how to prove that the maximum and minimum value lies between the plus and -1. Thank you, sir. I learned it the first time, a new way, how to prove that to the children of class 10 level.
Yes, with calculus, this becomes very easy, but to give them the feel, particularly about the minimum value,
Yes,
maximum
sir.
value, still they can get a feel from 0 to 90 degree, they can have a feel. And that's why this 0 to 90 degree business has made many of them feel that the minimum value is 0, but that the minimum value is -1, and for the generalized cosine theta and sine theta, this is extremely important.
Yes, sir. This is very nice way. Thank you, sir.
Again, Professor Ghosh. Hello.
Yeah, Shubhashu, yes, Professor Tramonto, please.
Now, the c square plus a square equal to 1. That is a square. Both of them are real numbers, positive. Both of them are positive real numbers. So necessarily, when a square max minimum is equal to 0, c square maximum you told the necessary square c square means that its square root should be either +1 or -1. But we can easily rule out +-1 because so we can take it to be c equal to maximum value of c equal to +1. Is there any harm in it? Or is there logical fallacy? I don't understand.
Now,
Nice. If I just tell directly that because c square and a square both are real positive, okay? And so if a square is 0, then c square equal to 1. Then maximum value of c square equal to 1. Then c equal to +1 or -1, but we cannot take -1, c is equal to +1.
no, that is okay. I made it little more rigorous. In fact,
okay.
Whatever you have said is inbuilt in this analysis, but this is much more rigorous, which directly say that also brings out the range in which cosine theta and sine theta lie.
Okay.
Any other reaction from the mathematics teachers? Any other reaction from the mathematics teachers?
Sir, I don't think we have any of them.
We do not have mathematics teachers here.
Mm, I cannot remember like right now, but uh, so I cannot tell you right now because I have to check the database.
Right.
So, so I don't think that we have any mathematics teacher here. So anyway, most of the teachers are from science background. All are from science background, and most are from physics. So I think they have to take class in secondary level mathematics.
Right. The other question which I raised last time also, of course, that was perhaps with the other group, that is angle dimensionless. We read a topic called units and dimensions. Now, and something having a unit, does it essentially mean that it should have a dimension?
Sir, may I comment?
Please, please.
Yes, sir. Actually, there is a discrepancy as far as whether angle and solid angle are units or not. Angle is definitely dimensionless, but that whether it possesses unit or not, there is still a, I mean, difference of views in the scientific community.
Please elaborate on that.
I mean, some are of the opinion that angle is actually a scale. It is not a physical quantity. So it is not supposed to have a unit. As such, the radian or degree, what we mention as units, those are scales basically, not units. Whereas the other part of the scientific community are of the opinion that it is a unit. I think you can please elaborate a bit more about it.
No, I think what you said is absolutely correct. In fact, it is the way of looking at it. Now, if you just define them as scales, you can define them as scales, but then among degree and radian, radian is more fundamental. Radian is more fundamental because it is the, as you know, that it is the angle subtended at the center of a circle by an arc whose length is equal to the radius. It is angle subtended at the center of a circle by an arc which is equal to its radius. So it is true for a circle this large, it can be a circle this small, it can be a circle this small, it can be a circle that large. So whatever might be the size of the circle, whatever might be the size of the circle, the angle remains the same. That is the angle subtended at the center by an arc of length equal to radius. So radian is a more fundamental measure of angle, and it's a very healthy debate to call it a unit or to call it a scale, because when you call it a unit, you always feel that it should have a dimension, whereas the angle is dimensionless, because if the arc length is s,
But actually,
radius is r, then theta is equal to s divided by r, and theta is equal to s divided by r means theta is dimensionless.
Radian points out to that situation only, that radian or angle is a dimensionless quantity. But if you call it, if you measure it in degree, then you are not sure. You have to, that it is dimensionless when you are using degree. Is it not? So
No, sir,
case,
you're just multiplying. You're just multiplying with a dimensionless quantity.
No,
If you have to convert radian into degree, you multiply by 180 by pi, and
no, that's
180
okay.
by.
But
So
that
you're
definition,
multiplying a dimensionless quantity with a dimensionless quantity.
no, that's okay. But when we are using radian, then definition of radian itself tells us that it is a dimensionless angle, is a dimensionless quantity. That I'm telling.
I think the guiding question can be. I think the guiding question can be. My guiding question, I related it to the matter of unit, but my guiding question is angle dimensionless? That's that much.
Yes, that can be put. That can be surely put.
And if you look at the expansion of cosine theta, sine theta, so on and so forth. So if theta has a dimension, suppose theta has a dimension, now you can add two, you can multiply two quantities having different dimensions. Say mass into velocity is momentum. You can divide two quantities having different dimensions. Mass divided by volume is equal to density. But you cannot add two quantities having two different dimensions. You cannot subtract two quantities having different dimensions. In order to be tenable for adding or subtracting, the quantities must be having same dimension. So suppose if theta had a dimension, then a havoc will be created. Same with e to the power of x. X cannot have any dimension. But for that matter, for any power, if something appears as the power of a quantity, it has to be dimensionless. And likewise, or say log of x has to be dimensionless. And similarly for cosine theta, sine theta, theta has to be dimensionless. Theta cannot have any dimension. And so these are the arguments in favor of saying that angle is dimensionless. But I think if all of you agree, then this can be a valid, what you call a valid guiding question.
Professor Ghosh,
Please,
Professor Ghosh,
please,
similar,
please.
similar situation arises when we, as you are talking of log, the bell and decibel. These are used sometimes for measuring the intensity of sound, sometimes even the measuring the for any logarithmic quantities. So whether they're in the sound or in the radiation, in frequency, everything, amplitude, so everything. That I'm telling that as a definition of radian and radian is a dimensionless quantity at that angle. Similarly, decibel, they are also dimensionless quantity. So we can rather have similar questions using those quantities also.
Definitely. So I think bell decibel is also more of a scale than unit.
Yes,
yes. Bell decibel is more of a scale than unit.
In that case, we can have rather, as Mr. Chandra has suggested, we shall be very aware of the situation, whether it is scale or unit, okay, because then things become very clear to everyone.
So no, but will you pass this as a guiding question, that is angle dimensionless?
I think it can be.
Right.
Similarly, so, even bell also, a decibel or bell.
Okay.
And bell is again a different problem. You see, when 2 radian means is twice the 1 radian, but 2 bell does not mean it is twice the bell.
Right, right.
So then it is again more complicated. So
you have to relate it to power in that case.
Yeah, power in that case.
Ajay, Mr. Shane had discussed with me separately about that particular problem, which I had assigned last time, that if the 3 feet of the perpendicular are given, is it possible to draw the triangle or not? Has anyone else attempted that? That is, in that problem, the 3 feet of the perpendicular were given, D, E, and F. And you are asked to determine whether or not the drawing of the original triangle is possible. Did anyone else attempt that? I hope you remember the problem that I had given the 3 feet of the perpendicular from the vertex to the vertices to the opposite sides, and I asked, with just by having these 3 points, whether it is possible to draw the original triangle or not.
So we are not getting any reaction right now, sir.
Pardon?
We are not getting any reaction right now, sir, from the participant.
Now I can give you the solution. Now this is called the pedal triangle, and you can definitely draw the pedal triangle. I'm keeping the main triangle at the background, but just feel that the main triangle is not there. These 3 points are there, so you can definitely draw the pedal triangle. Now, this is 90 degree and this is 90 degree. So, BFC and BEC can be considered as two angles at the circumference subtended by the chord BC of a circle. And so this is a cyclic quadrilateral, BFEC. This is 90 degree, this is 90 degree, and this is subtended by BC. So BFEC is a cyclic quadrilateral. And since BFEC is a cyclic quadrilateral, BFEC is a cyclic quadrilateral.
Same holds good for BDEA.
Pardon?
Same holds good for BDEF.
No,
No,
similarly, this is also a cyclic quadrilateral. Right. BDEA is also a cyclic quadrilateral.
Yes, yes, BDEA. Also cyclic.
BDEA. Now, since BCEF is a cyclic quadrilateral, now if you look from the point of view of the straight line BF, from the point of view of straight line BF, these two where I have put the cross, these are angles at the circumference. So angle BEF is equal to angle BCF. Angle BEF is equal to angle BCF. And BCF is equal to 90 degree minus angle B. This is equal to 90 degree minus the main angle B. By angle B, I mean angle ABC. Again, you look at this angle, Y. Now, this angle and this angle are same. Because, as I told just now, BDEA is a cyclic quadrilateral. And since BDEA is a cyclic quadrilateral, these two are angles at the circumference, angle E and angle F, with reference to the chord BD. These are angles at the circumference. So these two angles are equal. So this angle is equal to this angle, and this is equal to again 90 degree minus B because of the triangle ABD. So you get angle BED is equal to angle BAD equal to 90 degree minus B. So angle BEF and BED are one and the same. BEF and BED are same. So this straight line EB is the bisector. EB is the bisector of the angle DEF. Likewise, ADDA is the bisector of the angle EDF, and FC is the bisector of the angle EFD. So, whatever you find as the three perpendiculars of the main triangle from the vertices to the opposite sides, like this AD, BE, and CF are the perpendiculars from the vertices to the opposite sides, isn't it? So the perpendiculars from the vertices to the opposite sides, they play the role of internal bisectors when it comes to the pedal triangle DEF. When it comes to the pedal triangle DEF, they play the role of internal bisectors. And so what you can do, starting with the 3 points, you had DEF, you draw the triangle, you draw the angular bisectors, and they will meet at their incenter. And this incenter is actually the orthocenter of the original triangle. And then you draw perpendiculars to the internal bisectors. And once you draw perpendicular to the internal bisectors, they meet at the vertices of the original triangle. Is it clear? Or should I draw a clearer diagram?
Yes, sir, it is clear.
This was sort of the pedal triangle. These were the 3 points. So you had drawn the angular bisectors. B, E, F. And after drawing the angular bisectors at these points, now this is one of the angular bisectors, you draw the perpendicular. This is one of the angular bisectors, so you draw the perpendicular. And this is another angular bisector, you draw the perpendicular. So you get the triangle ABC. So that is how you arrive at the original triangle starting from those 3 points. The feet of the perpendicular, from the vertices to the opposite sides. Yes, Mr. Shen, is that all right?
Yes, sir. That's solution was very nice. I have never thought to taking the cyclic quadrilateral. So I use my intuition, but the solution you provide was very nice.
Any other reaction? We had reactions from Mr. Chandra and Mr. Shen. Any other reaction?
No, sir, it was absolutely nice. It was a new learning from my part. Thank you.
Okay. And another guiding question can be that does every conic have a diameter? Like, does a parabola, or make it more simple, does a parabola have a diameter? Does a hyperbola have a diameter? Does an ellipse have a diameter? Yes, Mr. Shen?
Yes, sir.
Does every conic have a diameter?
Sir, the point for parabola, it's going away from each other, and it is having a common vertices, or you can say where it is starting. And we don't draw in that way. I have drawn a parabola. There we have taken the focus, and then we are doing the perpendicular on each point and taking that measurement. We are cutting on the side, and thus getting the parabolic shape. Because for some experiment I need to make parabolic mirror, so I have drawn the parabola in that way. Yes, so first we have to fix the focus, then we have to take a point. Yes, sir. Then I am not remembering. Then by taking the point, we have to cut the arc on the side, and we have to keep measuring every time. I exactly forgot the procedure, but I have drawn a parabola with my desired focal length, because I need 4 centimeter focal length parabola. So I've drawn that and I've cut a piece of mirror over there. My experiment was there.
That mirror
This moment I forgot the procedure.
will be completely devoid of spherical aberration. Such a mirror will be completely
Yes,
devoid
yes.
of
And
spherical
every time we
aberration.
have
The
to take
focus
the
will not wander on the principal axis. Otherwise, you need to have paraxial rays.
Yes, sir.
So
Yes,
rays
sir.
very close to the pole. But my question was with diameter. In fact, the common misconception with the students is about the diameter. The word diameter as a length. They feel that
Sir, I
diameter
think
is
we have to draw the directrix first, and with the help of the focus, then only we can draw a parabola, keeping the distances same.
fine. But my question was that does a parabola have a diameter?
No, it is not supposed to have a diameter in so-called sense of the term.
In fact, there is.
In case of ellipse, there is major axis and minor axis.
You have not heard about conjugate diameters in an ellipse? Conjugate diameters in case
Conjugate
of
diameter. So yes, I recall, though not fully. Yes, I've heard the term. Yes, sir.
Mr. Ranjit Kumar wants to say something.
No, Mr. Ranjit Kumar is not here, I think.
Actually, I saw his photograph. Now, in fact, The misconception is about the
No,
length.
no. Ranjit Kumar is here. Yes, he is here, but we are not getting any reaction from his end.
And his photo flashed on the screen. That's why I thought that he
Yeah.
is going to react.
He is here.
Now, the word diameter is associated with the length diameter, which is twice the radius in case of a circle. But what actually is a diameter? Let us start with the circle. If you have a system of parallel chords, then the locus of the middle points of the parallel chords is a diameter. And a circle can have infinite number of diameters. If you have these parallel chords, then the locus is again a diameter. If you have this set of parallel chords, then the locus is again a diameter. So the generalized definition of, you have to know again, as I said about generalized definition of angle, generalized definition of trigonometrical ratios. Similarly, the generalized definition of a diameter is, it is the locus of the midpoints of a system of parallel chords. It is the locus of the midpoints of a system of parallel chords. So a parabola does have a diameter. Like a parabola has many diameters. If you have a system of parallel chords, say, for the sake of simplicity, let us consider this is a parabola and this is a system of parallel chords. Then this is the diameter. The locus of the middle points, and this can be determined. The locus of the middle points of the system of parallel chords is a diameter.
Professor Ghosh.
Pardon.
Hello,
Pardon. Yes, sir.
So can we not tell that as because at every point of a curve we can draw a tangent, and normal to the tangent is a diameter?
Normal to the tangent.
Because we normally it defines the radius of curvature in that way.
So normal to the tangent is a diameter. Normal to a tangent is.
But here also happening the same things. This chord you are drawing, ultimately it will be a tangent. It will intersect the curve parabola at certain definite point. Move it leftwards.
Yes,
so,
this also emanates from the circle, because the diameter will
yes, of course,
will be a normal to a tangent. But the more rigorous way of defining it is that it is the locus of the middle points of the diameter. All these questions are triggered to certain misconceptions which the students have. They will always say that a circle can only have diameter, parabola, etc. cannot have diameter. But this is
no, but that misconception should not be there, because we always used to talk of radius of curvature, okay, for parabola, for ellipse, and for every curve.
And in case of an ellipse or an hyperbola, say this is the diameter for this set of parallel chords. Then for this set of parallel chords, this will be the diameter. And this diameter is parallel to the other set. That's why these are called conjugate diameters. In case of an ellipse, these are conjugate diameters. And the same thing happens with the case of a hyperbola. I can determine the equation, but I'm not going into that rigor. Yes, please.
Sir, does it mean that in case of parabola you had drawn the diagram? So the axis of the parabola becomes the diameter of the parabola. Means, is it that they are coincident like that?
No. It depends on the slope of the chords. Now, suppose this is, then let me quickly work out the equation. Suppose this is a parabola and you have a system of parallel chords whose slope is equal to m.
Okay.
Whose slope is equal to m, and let the parabola be y square equal to 4ax. And any one of these straight lines will be having the equation y is equal to mx plus c. Here m is a constant and c is arbitrary, because it is denoting, it is the equation of a family of parallel chords. So m is constant, but c is arbitrary. Now, once you consider the intersection of these two straight lines, these two equations, that is this parabola and this straight line, then the corresponding equation will be mx plus c whole square is equal to 4ax, or m square x square plus 2mc minus 2a into x plus c, I hope my calculation is okay, plus c square is equal to 0. M square x square plus 2 into mc, right, minus 2a comes from the right hand side, into x plus c square equal to 0. So by solving this equation, you get the x coordinates of the extremities of a chord, and the midpoint will be x1 plus x2 by 2. The midpoints will be x1 plus x2 by 2 and y1 plus y2 by 2. These will be the coordinates of the midpoints. Now let us call them alpha and beta. Let alpha be the x coordinate of the midpoint, and let beta be the y coordinate of the midpoint. Now x1 plus x2 is equal to what? 2a minus mc by m square, isn't it?
Yes.
2a minus, because divided by 2, the sum of the roots will be minus b by a. This is a quadratic equation. The sum of the roots will be minus b by a. So 2a minus mc into 2 divided by m square, that divided by 2. So it will be 2a minus mc by m square. So this is equal to alpha. And beta will be equal to mx plus c. So beta will be equal to m into alpha plus c. And m into alpha plus c will be, on erasing this part, I'm erasing this part. M into alpha plus c will be equal to, you multiply this by m. So this will be 2a minus mc divided by m plus c. So this c and c cancels. So beta will be equal to 2a by m. Now this is constant, this is fixed. Because m is a fixed quantity, c is not, but c gets cancelled. And therefore, the locus will be y is equal to 2a by m. So this is the equation of the diameter. So the diameter will be parallel to the axis of the parabola. Madam was referring to the axis of the parabola. The diameter will be parallel to the axis of the parabola.
Okay. Okay, sir.
And its slope will be the reciprocal of the slope of the parallel chords, the common slope of the parallel chords. So similarly, you can determine the equation of diameter of an ellipse.
Negative. Negatives.
No, negative. No. In this case, it is not negative. It is very much positive. Y is equal to 2a by m.
Oh, yes, yes.
Sir, is the diameter necessarily parallel to the axis?
Yes, yes.
I mean, it can have many diameters.
It can have many diameters, but the diameter will be parallel to the axis. Because the diameter, if the slope of the system of parallel chords is equal to m, the diameter will be 2a by m. So y is equal to a constant, and y is equal to constant means it would be parallel to the axis of the parabola.
But m can vary, right, sir? For different sets of parallel chords.
M can definitely vary. Suppose you have a system of parallel chords like this. Then
Yes, sir. That was what I meant.
Then this would be the diameter.
Yes, yes.
But again,
And that has not to be necessarily parallel to the axis.
It has to be. It has to be parallel to that.
Happening.
The diameter will be parallel to the axis.
Because if you see, y is actually always independent of.
Mr. Chandra, you see, m is a constant for a set of parabolas. I beg your pardon. For a set of chords, m is a constant. So 2a by m is a constant. Unless m is a constant.
I mean, for different set of chords.
No, for Professor Ghosh, for a given family of straight lines, m is constant. But if you consider another family of straight lines, the name is a different.
Yes, sir. That
for another family of straight lines, m will be another constant, right?
Yes.
For another family of straight lines, m will be another constant. So again, the locus will be
straight. Okay. It will be a straight line again.
Again, parallel to the x-axis.
Yes.
Isn't it, Mr. Chandra? Aren't you convinced?
Yes, sir. The equation shows so, but I can't figure it out geometrically.
No,
I'm
trying to help you.
Now, why equal to C1, C2, C3? That way it will happen.
I
Y
understand
equal
from
to,
the equation part, it is clear. But from the geometrical point of view, I was trying to understand.
I'm trying to help you out.
Okay.
In this case, can you figure out that this is the diameter? Roughly, locus of the middle points of the parallel chords. Then if you have this system of parallel chords,
Okay, okay, I got it. Yes, sir.
then this will be the diameter.
Yes, sir.
So every time it would be a different diameter. Like in the case of a circle, there are different diameters.
Yes, sir, I
But
got
each,
it.
each diameter is parallel to the axis of the parabola.
but their diameters are having different straight lines with different gradients
Right, right.
in case of circles.
Even in case of ellipse, diameters will be having different gradients.
Yes, yes. But parabola,
Diameters
this
will-
unique thing is happening.
Right, right. It would be having different gradients.
Mm.
And in case of ellipse, it would turn out to be that if you have a system of parallel chords parallel to y is equal to mx, then the diameter will be y is equal to m prime x. And suppose it comes to y equal to m prime x, then for y is equal to m prime x, this will be the diameter. That's why they are called conjugate diameters. For y is equal to mx, if the diameter is y is equal to m prime x, then for y is equal to m prime x, the diameter is y is equal to mx. That's why these are called conjugate diameters.
M into M prime is -1.
M into m prime is -1 in the case of a circle. For an ellipse, it would be minus b square by a square. I can
Oh,
work it
yes,
out.
yes. Right,
For an
right.
ellipse, it would be minus b square by a square.
B square by square. Yes, sir. Right.
After discussing so much about conics, let me give a particular problem which may appear to be a problem from coordinate geometry, but it has very important linkage with physics. Suppose this is a point from which I am firing bullet to a target, and this is a target. This is a target, and this is a targeted point on which I am. So this point is more important, and this is the point from which I am firing the bullets. So bullets are being fired, and someone is walking along a track. Someone is walking along a track, and he always finds that the sound of the bullet, but that is sound of the firing, and the sound of the thud of the bullet striking the target. These are two sounds. The sound of the bullet, that is the sound of the firing, and the sound of the thud striking the target. So he gets them simultaneously. He could register them simultaneously. So what is the track? Battery is running low. So what is the nature of the track? Is it a parabola or a hyperbola or an ellipse or a straight line?
So just give.
Definitely. And you'll also have to tell the linkage of this problem with physics, with a particular phenomena in physics.
So could you repeat the question once more?
Please, I'm doing so. My battery was running low. A bullet is being fired from a point A. So these two are fixed points. A is a fixed point from which bullets are being firing, and B is a point on a target. So bullet is being fired from A to B. Now the sound of the gun, and the thud of the bullet striking the target. The sound of the gun and the thud of the bullet striking the target, they are simultaneous. That is, he is walking along a track, and he's always finding that the sound of the bullet and the thud of the bullet striking the target can be heard simultaneously. Then what is the nature of the track. Is it a parabola? Is it a hyperbola? Is it an ellipse or a straight line?
Sir Devmallo.
Yes, Mr. Shen, please.
Sir, from time calculation, I am getting the, suppose T1 is the time after which the person hear the firing sound, then that should be equal to the time taken by sound to travel from the target to person plus the time taken by the bullet to hit the target.
Exactly, exactly.
So
Exactly.
I got an equation. I'm just translating to its distance part. So just give me some time.
Okay, okay. What Mr. Shane was telling, let me translate that mathematically. Let D be the distance, and let this be a particular position of the person P, person on the track P. So AP is a variable, so is PV, but AB is fixed. Now PA divided by the velocity of sound is equal to AB divided by the velocity of the bullet plus PB divided by the velocity of sound. Is it okay, Mr. Shen?
Yes, sir. Yes, sir.
This is what you are telling me.
Yes, sir.
So PA minus PB divided by velocity of sound is equal to D divided by.
This is constant.
So PA minus PB is equal to D into Vs by Vb, and Vs by Vb is a constant. D into Vs by Vb is a constant. D is a constant, Vs is a constant, Vb is a constant. So PA minus PB is a constant.
Yes, sir.
And if PA minus PB is a constant, then P moves along a
ellipse.
Hyperbola, sir.
Hyperbola.
For ellipse, PA plus PB will be constant. So for hyperbola,
yes,
PA minus
yes,
PB
yes,
is a constant.
Yes, yes, PA plus PB.
A and B as the two foci.
Okay, okay.
With
Actually,
A and it would be a hyperbola with A and B as the two foci.
Yes, I understand. This actually happens in the interference fringes.
Exactly.
I
I wanted to link it with that phenomenal form
there
which we get after
fringes
Young's double slit experiment.
Yes.
From Young's double slit experiment, S1, say if the slits are S1 and S2, then S1P minus S2P is equal to n lambda, which is a constant. So actually it is happening in the three-dimensional space. So these are not hyperbolas, but hyperboloid. The interference fringes will be hyperboloid. And what we see on the screen is the two-dimensional projection of the fringes in the form of hyperboloids. Mr. Shamanto, any comment on this?
No, all right. It's fine. It's
no, but the linkage with physics, you can please elaborate on that.
It's fine. Actually, I was confused to some extent because you see with billet split lenses, two things happen. Depending if the split lenses are separated vertically, then we get in the screen, we get this relation is exactly valid, and we get the elliptical fringes. But if we change the, shift the fringes along the axial direction, then we get the hyperbolic fringes.
Mr. Shen, are you convinced?
Yes, sir. Got it.
So this can be linked with that particular problem in physics that
Yes, sir.
I have another commitment little while later, so I'll try to wind up, but still I can have some time. Another problem I had assigned earlier, so it would be a repetition for those who are listening it for the same for another time. But then I find it quite interesting. It is about tossing of a coin. Now, as you know, in the case of, say, of a cricket match, the two umpires, the match referee, and the two captains, they go out for the toss. And many a times, both the umpires may not be there, but the match referee is always there, and the two captains are there. And one of the captains, normally the home side captain, carries the coin. Now, they walk out to the center of the field, and then the home side captain puts his hand inside the blazer, puts his hand inside the pocket of the blazer, and brings out a dice in place of a coin. He says that I could not bring a coin, I have brought a dice. So the match referee said that then toss will not be possible. Now, is the comment made by the match referee correct?
No, sir. I mean, the outcome can be brought up by odd and even
Great.
thing.
So the match referee is not correct. He said that yes, we can still go ahead with the toss, but then the captain should not call the possibilities 1, 2, 3, 4, 5, 6 because there are 6 possibilities now. He should not be calling the possibilities. He should call either even or odd. Like in the case of coin tossing, he would have called head or tail, because in either case the probabilities were same. In the case of coin tossing, probability of head plus is equal to probability of tail is equal to half, and in this case also probability of even is equal to probability of odd is equal to half. So,
Sir,
yes, please.
sir, it need not be required to be odd and even. Any three number, separate number, they can select and probably also come up.
Yes, that can also be done. Very right. But then the numbers should be mutually exclusive. 1, 2, 3, 4, 5, 6.
Whatever means any different set of number they will pick. Then the probability also.
Very right. It can be less than equal to 3, greater than equal to 3, greater than equal to 4. Less than equal to 3 or greater than equal to 4. Or any set of numbers, as you have said, 1, 3, 6, 2, 4, 5, any set of 3 numbers. But
Yes,
with odd and even, we can make life less complicated for the captains, because they already will be having the tension of a match ahead, and so let them not teach so much of mathematics there itself. So, but whatever you said is very right, Mr. Shen. It can be any set of 3 numbers which are mutually exclusive with the other 3 set. But my question is different. In the next match, the captains walks into the arena, the central part of the field where they do the tossing, and he brings out a coin from his pocket, but he declares that he knows that the coin is biased. He tells that the coin is biased. So if the coin is biased, then pH is equal to PT is not equal to half. If the coin is biased, because pH equal to PT follows the definition of probability, which says that probability is equal to the number of favorable outcome divided by the total number of outcomes, provided the events are exhaustive, they are mutually exclusive, and the third condition is very crucial, that they are equally likely. They should be exhaustive, they should be mutually exclusive, and they should be equally likely. And if there is a bias, then they are not equally likely. So pH is equal to PT will not be equal to half. And he declares that he knows in unambiguous terms that the coin is biased. So this is what. And again, the match referee says that tossing is not possible. Now, is the match referee correct? That is the guiding question.
Sir, may I say?
Please, please, please.
The captain know the biasness of the coin, who is to whom the coin belongs to, but the opponent still it is he have no clue about it.
No,
So
no.
if the opponent,
The clue is given by the tossing captain. He in all fairness had come and declared before tossing the coin. This is a hypothetical situation, but just for framing the problem, I have said that he comes to the ground and declares that in all fairness that this is a biased coin.
He must
but sir,
show the nature of
if
the
he
bias
don't
also.
declare that which side it is biased, for opposite captain, it is clueless. Again, his probability will be 50-50 to detect what biasness is there.
Not only for the opposing captain, even for the tossing captain, even if he knows that it's a biased coin, he also cannot predict that whether head will come or tail will come. That way it is okay. But then later it can be questioned at the court of law, because coin tossing is very crucial. It decides the fate of the game, isn't it? At times it decides the fate of the game. Why at times? And most of the time it is so crucial, winning the toss. So the game after it is played, but it comes and it is surfaced that the toss was done with a biased coin, and which was known to the two captains and most crucially the match referee. Then the result of the match can be declared null and void by the adjudicator. But what you said, Mr. Shen, is very correct. Not only the captain who is going to make the call, the captain who is going to make the toss, knowing that it's a biased coin, he also will not be able to predict that what would be the outcome, either a head or a tail. So that way, tossing can go on. But the crucial thing is that he knows that the coin is biased, and he has declared that he knows in an unambiguous term that the coin is biased. So will the match referee allow the toss to be held with such a coin? Despite what you have said is correct, but I have given, of course, when you have to stretch your imagination that a match is played and it goes to the court of law. If it is an international match, then it has to go not to Kolkata High Court or Delhi High Court or the Supreme Court, but to Hague, the International Court of Justice. Yeah, these are stretching things too far. But in order to validate my guiding question, you have to accept all this ifs and buts.
Sir, how much biasness is there? Is there a provision to know that how much biasness is there?
No, he only knows that it is biased.
Is it mandatory to toss the coin?
Yes, madam. It is mandatory. It is mandatory to have the toss. So what is your alternative?
If I use my both the hands and they have to guess in what hand I have the coin.
Acha. But then there is one thing, madam. No, but what you have said is very right. I have never thought in that way. And this can be a possible solution. But coin tossing is something that even if the person who is in the act, that is, say, in most of the cases, the home side captain, he would also not be knowing what is going to be the outcome. But if he holds the coin in one of the hands, then he knows. In fact, when we were little kids, we were not even given a 50 paisa or a 25 paisa coin, because that the value of that was quite high during that time. But we go to the playground, and then we were quite at a loss how to do the tossing, and then we pick up a blade of grass, and then as you have said, we hold it from the side away from the opposing captain and throw it, or play act that I am throwing it, but we may not be throwing it, and then ask that whether I'm still holding the blade of grass or not. So these we used to manage. But I'm talking about the situation in an international match. But then, madam, what you have mentioned is something which I never thought of.
Sir,
Yes.
biasness will be only revealed when the coin is tossed. If the coin is not tossed and the person who is tossing, he put the coin on the palm without tossing it, and he can flip and ask that what direction is this, then the biasness of the toss is gone.
Tossed only for several times, otherwise cannot find the biasness.
No,
Now,
it is not thrown at all. The people can shake
again, Mr. Shen, what you have said is
and close it.
okay. Okay. Now then, just one small modification to the statement you said that biasness gets revealed. Biasness also does not get revealed, because revealed is perhaps not the right word. You say that biasness come into play. Biasness matters when the coin is tossed and you are not tossing it. What you said is almost same as what Madam has mentioned. Well, I'm trying to look at it mathematically. The way Madam said, or your this option, these are acceptable. These are definitely acceptable. So in any case, the match referee is wrong, and I'll also prove the match referee wrong, but with more mathematical rigor. See, let the probability of head be equal to P. Let the probability of head be equal to P, and P is not equal to half now. Then probability of tail is equal to 1 minus P. Now, what is probability of two consecutive heads? It is P into P, that is P square. What is probability of two consecutive tails? It is 1 minus P into 1 minus P, that is 1 minus P whole square. And what is the probability of a head followed by a tail? It is P into 1 minus P. And what is the probability of tail followed by a head? That is, this is probability of head into probability of tail. That is P into 1 minus P. And this is probability of tail into probability of head. That is 1 minus P into P, which is also equal to P into 1 minus P. So probability of head tail is equal to probability of tail head. Probability of consecutive head tail is equal to probability of consecutive tail head. So one way of still make the toss survive is to toss it consecutively, and the tossing captain will ask the opposing captain that in two consecutive tosses, is it going to be tail head or is it going to be head head? Suppose in two consecutive tosses it comes to tail tail or head head, then the process has to be repeated till such time the two consecutive tosses do not give you two different things. But he can ask that in two consecutive tosses, is it going to be tail head or is it going to be head tail? Because these two probabilities are same, as in the case of probability of head and probability of tail of an unbiased coin. So in two consecutive, the coin has to be tossed at least 2 times. And what would be the outcome? Will it be tail head or head tail? Then the process of tossing survives. Is that all right, Mr. Shen?
Yes, sir. Yes, sir.
I want to, but I definitely compliment you and Madam. I think it was Rinku Madam who was telling. I
No,
think.
no, 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 no. Mrinalini madam. Rinku
Oh, acha,
madam
acha,
is
sorry,
in
sorry.
Bengali session.
Oh, acha, acha. Sorry, sorry, sorry. So thank you, Mrinalini Madam, Madam Deshmukh. That what you said is very much acceptable. But this is how you look at it uh, from the point of view of mathematics. That you apply some mathematical rigor and you make the process of tossing survive.
Acknowledge this. When I do my physics in the class, I don't do the mathematics so rigorously, but I think you will be the reason for me to try to attempt it doing so further.
Please attend this in the class. Please attend this in the class, and this would be a good experiment.
Example of potential gradient which you had shown us in the last
Yes.
lecture.
Right.
Definitely that in my class as well.
Yes, yes, yes. These are direct linkages of mathematics with physics. And
Sir,
so, yes, please. Yes, please.
I think that even if the tossing captain knows that which side is biased,
No, he does
still
not
it
know
is
which side.
operable.
So, Mr. Chandru, he does not know which side is biased. He knows that
I
the coin.
understand, but even if he knows, then also it is doable. Is it not?
Oh, that's what I answered at the very beginning. That he knows it is biased. Huh? In order to, practically speaking, in order to bring home this mathematics,
I understand. Yes, sir.
I created all these stories.
I
Huh?
understand.
Even if he even if he declares that the coin is biased, he does not know what would be the outcome, and the other captain definitely does not know. He does not. But what he knows, once he knows that the coin is biased, it should be biased on one particular side. I'm not giving you the value of p, whether it is more than half or less than half. So he would be knowing that in 100 tosses of the coin, 70 times it comes tail and 30 times it comes head. So it is biased towards tail, which he might be knowing. But that does not mean that in that particular toss it would come head or tail. So toss can go on. But I'm
Yes,
saying
sir.
I'm sketching things too far when I'm acting as the devil's advocate. The devil's advocate will say the losing team that you know that the toss was done with a biased coin, so you file a case at the International Court of Justice. If that case will be won by the losing captain, if he can establish that the coin tossing was done with a biased coin. Again, stretching things too far. So just to make my mathematics come alive, I created these stories. But whatever Madam has said and you have pointed out, these are also valid. But in any case, the match referee is proved wrong, isn't it?
Absolutely, sir.
Sir, I have a question.
Please.
Uh, Not means this way, in some other way it came in my mind. While I am visiting the Digha Science Center,
Right.
there is a toss board, electronic toss board is there. And the people is visiting, they can toss and it comes head or tail and that is counted. So when I first time visited that board, I find head count is giving around 630 and tail count is coming around 400. So then it's come to my mind that is the probability what we are applying is only applicable for a very large sample size, or it can't be done with the means restricted number of toss. And then I tried to my class. Again, I find the similar type of result that it is not giving 50-50 thing. So how to
No,
deal
that means
with that?
no, that means the coin is biased. If for a very
And then
large number, again it has to be the test of biasness, which is done through the chi-square test. It can be done through that test, and then again you cannot tell with 100% assurance. There are two levels of significance where there can be sampling error, that is 1% level of significance and 5% level of significance, up to which you can say whether you have to frame a hypothesis that the coin is biased, and the alternative hypothesis is coin is not biased, and it can be tested using the chi-square distribution, and from that you can arrive at a conclusion. Of course, again within the limitations of the confidence level of 1% or 5%.
Okay, sir.
A very quick application of mathematics. Well, listen to my question very carefully. While moving out of my house, which we are not doing these days, I wear socks and shoes, and when I returned, I open my socks and shoes. So the opening of socks and shoes is an inverse operation of what I had done. While I beg your pardon, removing the socks and shoes is an inverse operation of wearing them. I repeat, removing socks and shoes is an inverse operation of wearing them. Now, is it commensurate with the inverse operation which we have in algebra? Is it exactly commensurate with the kind of inverse operation we have in algebra?
It should not be.
Does my question make any sense? That removing socks and shoes is the inverse operation of wearing socks and shoes.
No, I think this
This is
should
my
not
first
be.
statement. Now, is this exactly commensurate with the inverse operation in algebra?
Professor Samanta was saying something. Sir, please repeat.
No, in the first question,
I was thinking that he will follow that up with an explanation.
Actually, these things are happening after a long time gap, and many things have happened. When you have gone out of the room and coming back, in the meantime, many things have happened. So I think, at least from that count, I can tell these two operations are not identical.
Yeah, my vision was very simple. Say 3 to the power of minus 1 is 1 by 3. 4 to the power of minus 1 is 1 by 4. So 3 into 4 to the power of minus 1 is 1 by 3 into 1 by 4, or 1 by 4 into 1 by 3, isn't it?
That means you are asking whether these things are commutable or not. Commutative or not.
Yes, the order is does not hold, so these two cannot be equated.
But in case of matrix,
Yes.
in case of matrix, you have AB inverse is equal to B inverse A inverse. In case of normal algebra, AB inverse, in case of normal algebra, AB inverse can be B inverse A inverse, or even A inverse B inverse. There is no difference between them in case of normal algebra. But in case of matrix, it is B inverse A inverse. That is, when you wear first socks, then shoes, and when you remove first shoes, then socks. So it is commensurate with matrix inversion, but not with the usual algebraic inversion. Does it make some sense?
Yes, sir. It can be related. I was wondering about the type of operation you are trying to
I
make.
said inverse operation, so this is inverse
now
operation.
I understand you are talking about the
This is inverse operation.
Yes, sir.
This is inverse operation. So that's how I brought it.
Yes, that is okay. But whether it is algebraic, any sort of algebraic or matrix.
Basically, it comes from the concept of commutation. It comes from the concept of commutation, and so that is applicable to matrices, not to the numbers. For case of numbers, they always commute. 4 into 3 is equal to 3 into 4. But in case of matrices A into B may not be equal to B into A. Like say two consecutive operations. You normally would take a glass of water before sipping a cup of tea, but you don't do it the other way around. So if you perform this operation on your stomach, so the transformation of the stomach after having a after having a glass of water, and then again the transformation it takes place by subsequent operation by a hot cup of tea is not the same if you do the other way around. That is, you first do it with a hot cup of tea, followed by a glass of cold water.
These things
And,
have been,
and the second one is not advisable also.
these
If you are
things,
thirsty, then you have the water first and then you have tea. So these two operations do not commute. And
these,
they are more commensurate with matrices. Yes, Professor Shamanta was telling something.
actually, this situation has been amply explained in a rhyme. You see, Humpty Dumpty sat on a wall. Humpty Dumpty had a great fall. All the king's horses and all the king's men could not put together Humpty Dumpty again. These two things are not commutative.
So I'm afraid I have another commitment. So may I take leave? In fact, Anirban, can I take leave?
Yes, sir. If you have any commitment, you can, sir.
I had a few other examples, but we can discuss
Okay,
it
sir.
sometime again.
In your absence, I like to discuss some simple mathematical operations involved in physical concepts. But as you will be leaving, so we shall discuss the things later.
Now, before I leave, just I gave an array of examples. In fact, my idea was to bring home those concepts in trigonometry, particularly the maximum and minimum values of sine theta. But I'm just making a quick summing up, and then about the dimensionality of angle, and then also the idea of diameter of a conic, and then that particular problem of that firing of the bullet and the target and its relation with the concept of interference by division of wavefront. And then, of course, this probability concept and this inverse operation in matrix. So these are certain things, and if you can reflect on them even later, I'll be very happy. And also that particular problem in geometry where the 3 points were given and you have to reconstruct the triangle. So if you can reflect on them, if you have not been able to tell something now, please feel free to reflect on these at a later stage. Thank you very much.
Thank you very much, sir.
Professor Singh, Professor Ghosh, hello.
Hello. Yes, I'm still
Yes,
here.
thank you for an illuminated discussion on the mathematical aspects of certain situations.
Thank you.
Thank you, sir, for sharing such things with us and illuminating us. And now I'll go to Professor Samanto to take the charge. So I'm handing over the charge to Professor Samanto.
Yes, we have half an hour or so left, so we can discuss some things. You see, I have got on mind because it's some simple questions which are very much related to physics program. You see that in a simple pendulum, normally we see that amplitude is proportional to, energy of a simple pendulum is proportional to its square of its amplitude. I may put on question like this. It is found that energy of a pendulum is proportional to square of the amplitude. What is the theorem for circles that need to prove this? Do you understand what I have told? Hello?
Yes, sir. We are hearing.
In a simple pendulum, when we excite the pendulum bob with an amplitude, say A, then we know its energy is proportional to square of the amplitude. Actually, this can be derived from using a theorem on circles. What is that theorem?
So I would like to welcome the participants If they have any comment, please make it. So I want to know, is it clear? Is the message clear to the participant,
So
or
I am explaining the fact, you see, that suppose the pendulum of length is excited from its position of rest to a point A. Okay. So actually the pendulum will oscillate over an arc of a circle whose radius is the length of the length is the radius of that circle, and diameter is twice L. So naturally, when we are actually lifting the bob, actually we are lifting the bob. That is how we can give the energy. mgh. If m is the mass of the bob, g is accelerated gravity, and h is the height through which it has been lifted. So naturally, this h is actually, sorry, energy is mgh. And if you draw the circle of radius L, that is diameter twice L, then you can see that actually two chords intersect. Two chords intersect. One is the diameter, and another is the another is that two points that connect the circular path of the pendulum bob, A, B, say. So, and naturally, actually, two chords intersect. One of them is the diameter. So, and we know if the two chords intersect, then the rectangle formed by the two segments of one chord is equal to the rectangle formed by the two parts of another chord. So from that concept, actually, we can determine how much the pendulum has been lifted vertically, h. Okay.
Yes, sir.
So, hello, other please.
Yes, I got it, sir. Devallo.
Yes, and others. So it is simple. I think this geometry is taught perhaps in class 10 standard. Anybody?
and I think it would be better if anyone can draw draw these things and explain, so that will make it more visible. Sir, can you draw it in whiteboard of Zoom?
Doing that PPT.
Okay, okay, okay. So in between, if anyone like to discuss on any other point, they can please they can come forward, and we may take that point for
Or I
discussion
can
also.
discuss a second program. Yes, Abid is adjusting it. I can discuss the second program, you see. Nowadays, we are very much rather hearing about what is called the flattening of the curve. Is it not? Yes, now things is coming. Yes.
Okay, sir, it is visible now. So now you can explain.
Okay, that I'm telling. Now everyone sees the screen. Hello.
Yes, yes, yes. We are seeing your screen. You just please explain.
Okay. At the
Details
point
are
O, the
visible.
bob is there. Okay. And from O to A, I have lifted the bob from O to A. And from the ground, it is lifted by a distance xa equal to h. And you see that pendulum is suspended from the point S, that is the circle, center of the circle, whose radius is SO, means length, L. Understand? So you see that actually, if when you draw the full circle, then the point opposite to O is O prime. So O prime is the has the length twice L, and you see twice L. So the diameter O prime and AB intersecting each other at the point C, and you find that BC into CA equal to OC into CO prime. CO prime is, by definition, you see, it is actually twice L minus H. So H into twice L minus H equal to A into A prime. If we assume that energy is conserved here, so A equal to A prime, that is H equal to H prime, that is O equal to A prime. From that you find twice L minus H equal to A square. A is the amplitude, you see, because angle is theta is small. So actually OA is the amplitude, but as theta is very small, so we can assume CA equal to A is the amplitude. So twice L minus H into H equal to A square. As H is very small, twice L H equal to A square. So H equal to A square by twice L. So that is the amplitude. Now, because you see energy at the point is equal to mgh, that means energy is proportional to the height h. And so I have seen, we can calculate that h equal to a square by twice L. That actually it is due to the fact that amplitude remains the same because of principle of conservation of energy. We are assuming that thing. No energy is lost due to friction or otherwise. Okay, have you seen it? Hello.
Yes, sir. Yes, sir.
Yes, sir,
So,
it is visible, and just that approximation has to be done. I was just wondering about that thing only. That
which approximation?
I mean, the arc is actually approximated to this, to that perpendicular distance, A or A dash, as you
Naturally,
mentioned rightly.
I have drawn the circle with so small a radius that, but because
Yes, yes,
you are always used to tell your student that angle theta should be less than 4 degrees. But
yes,
what is
sir.
4 degrees? It is very small, is it
In
not?
radian measurement, yes, yes.
So A equal to CA, no problem.
Yes, sir.
In fact, in that to that point, they will understand how small is the angle and how the angle can be actually determined here, because he knows the amplitude. He can easily, suppose if you take a string of length 100 centimeter, then actually even if you displace the lift the by say a distance amplitude is 10 centimeter, then that angle in radian is 1/10 of a centimeter, 1/10 of a radian. That is almost less than 6 degrees. Is it not? So now I think things are that you can see, and you can tell your student that from this theorem of circle, where we have assumed that the arc, the chord OO prime is divided by the diameter OO prime is intersected with the chord AB, and the chord AB is perpendicular to O prime. It is not needed, but here the extra advantage is because it is perpendicular. That is why we can calculate actually H into twice L minus H equal to A square. That is C square equal to A square. Okay. So can we put a question before that, the students? Of course, we have to give them the informations that you have to use this, you have to define the, because you know, and then when you are lifting the pendulum bob through the radical distance, it is acquiring a potential energy mgh and the point A, and at the point A, it has no other energy, that is kinetic energy is absent. So total energy is mgh, and when it is moving from A to A, it is actually gaining kinetic energy, and from O to A, it is losing kinetic energy at the point B. it is actually having the same energy mgh. That means H equal to H prime. So these things are to be explained before them, I think, and the energy conservation is also. So if all these things are their previous knowledge, they can draw the circle and prove that yes, amplitude square of amplitude is equal to is proportional to the energy. Hello, Mr. Sen. Hello.
Yes, sir.
Is it okay?
Yes, sir.
And any comment, please?
No, sir. I never thought in that way. First time I am get introduced by you.
Okay,
And
then.
never thought in that way.
So should I go to another point, or will you suggest some other question?
Sir, please show something more, sir.
And actually, in this nowadays, everybody is now making certain calculations regarding the flattening of the corona curve. In the world total, what is happening in the total world total, and in our country also. You see, so if you go through the number, then if you just see the numbers, then practically that numbers, proportion fraction of the number. If the number is increase in number in a day is dn, and suppose number is n, then we can see that dn by n is almost over a certain period. dna by n equal to n itself. dn by n, sorry, dn by dt or dn by n is actually k into dt.
Sir,
Suppose today number of cases, positive cases n. Okay. After next 24 hours, we find that increase is dn. Okay. So you can see that dn by n or is proportional to the time, that is 1 day interval if it is dt. The dn by n is proportional to dt. That is that here dt is the interval, means 1 day I'm taking. So from that, can you draw the curve? Or if that is happening, what should be the nature of the curve? We can ask that question. Am I understandable, or should I repeat the problem again?
Sir, this is the case of radioactive decay, I suppose.
Yes.
If it is a negative sign is assigned.
Yes.
So dn by dt is proportional to minus n.
Yes, exactly. Similar things happen if you see that in this pendulum motion also. Change in amplitude over a time, say over a time dt is proportional to the change in fraction of amplitude change. dA by A is proportional to minus dt, minus k dt is equal to minus k dt. So from that we can actually define the amplitude decay, exponential decay in amplitude. But here in the corona case, you see that it is actually that change is dn is increasing, dn is positive. Suppose today the number of corona infected case is n. Tomorrow after 24 hours it will be n plus dn. This change in dn is proportional to n itself. If we assume that, in fact, over a certain period, say over a week, we can see 3-4 days at least, we can see that actually this dn is proportional to n. Afterwards, it is changing. That is why flattening of the curve arises. But if we, over this small period, you will see that dn by n equal to k into dt. Here, dt equal to 1 day. And if you integrate the curve, you will get the exponential curve. And what happening, you see, and people are telling that after every 7 days, sometimes initially after 3 days it was doubling. Afterwards it became 4. After 3, 7, 9, 11, 10. Now it is actually more than 12 days. So that is the constant k is changing. It is completely decreasing. So necessarily it is true that curve sometimes the curve will be flat when dn will be almost 0. That there may be some infected persons, but that increase will be almost nil. that they are trying to find due to these random tests. So actually K is the constant. dNdt is equal to minus K into N, sorry, plus K into N. In radioactivity, dNdt equal to minus Kn, but here dNdt equal to plus Kn. This K is not a constant quantity. Over a period, say 4-5 period days, it is constant, but afterwards it is gradually decreasing. And this K value is actually the determining factor whether the graph is flattening or not. So we can ask a question, if someone actually really observes the data, then how the flattening is happening. Even one can predict also that at what time it will flatten. Of course, other things remain the same.
Sir, I think by taking the measurement, we are just curbing its spontaneous spreading. That's how we are trying to flattening the curve. We are
Yes, of course,
not allowing it to go as is.
That is they are resorting to lockdown.
Yes.
That happens. If you analyze the data from say day 1 to till this date, you will see that it is really happening. The K factor is continually decreasing. So this is another. I have another question. It is my favorite question in physics. You see again. You have seen that in a convex lens forming real image, if the object and the screen distance is fixed, then to define positions of the lens, we can get to a real image. Is it not?
Yes, sir.
Everybody has observed that thing. In fact, done that experiment.
And
so suppose.
Formula is also.
Hello. Yes.
A mathematical is also there. Are equal to, I think, you forgot the formula.
Okay, now I have a different problem. In fact, this problem I have solved to solve. I had to solve another problem. You see that I am used to do. I told you earlier that we are used to do experiments on light using a filament lamp as the source. If the filament lamp is the source, then it is actually situated from the front surface to a distance. It is not exactly coincident with the front surface. So there is a distance between the front surface of the bulb and the filament lamp, is it not? So naturally, it is really difficult to measure the object distance accurately. Some errors will be there undoubtedly, to the order of say few millimeters at least. So I had to eliminate these errors. Okay. So what I observed that if the lens is position of the lens is changed twice, then two real images are formed. So suppose if we take the image distance as a variable, we can easily locate that for two image distances, say V1 and V2, we get the image at the screen. So we can, from the theory of quadratic equation, we can construct a quadratic equation in V, whose two solutions are known to us, V1 and V2, because it is V minus V1 into V minus V2 equal to 0. And because we are measuring only the object distance, so we can avoid the filament position of the filament. Understand? So I have avoided one problem using mathematics, you see, because we have obtained a quadratic equation in V minus V1 into V minus V2 equal to 0. And we can again relate this equation with 1 by V plus 1 by equal to 1 by F, eliminating and writing U plus V equal to D. We can eliminate U from that equation. So we can get two quadratic equations, one from theoretical ground, another from the experimental observations. And we compare these two equations, we find focal length without bothering anything about the position of the filament, the object. So I can use this experiment to construct a guiding question. And you can suggest, of course, what should be the guiding question. Am I clear to all of you? Hello, Mr. Chandra?
Yes, sir, I'm following.
Okay. But Madam Deshmukh or Snehal are not telling anything.
We'll have to rerun the videos to
Hello?
think over, sir. Need more time.
No, I think you are used to the situation where image is formed using a convex lens with the screen with the distance between the screen and object fixed. Necessarily for real image, we have to have the distance greater than four times the focal length. In fact, that otherwise you cannot get the real image there. So with that situation, as because we are using a filament lamp whose filament position is not exactly rather known, its position is to some extent uncertain, but still we can get we can do the experiment for finding the focal length, just measuring the image distance. We don't need to measure the object distance at all. Okay, if we construct a quadratic equation, because for the two image distances we get two images.
So then what will be the guiding question from you?
That means just is it possible to construct? We can tell what we have. I have talked that I can tell it that using a filament lamp as with the filament of a filament lamp is taken as the object, and if skin is taken, the object, the filament lamp, object and the skin has a fixed distance d, and the lens is placed in between, convex lens, and we see that for two positions of the lens, we can find the image, two images on the screen. So just measuring is it possible to construct a quadratic equation in V in the image distance to find the focal length of the convex lens? That is the guiding question. Because here students know everything. In fact, they know also the use of quadratic equation and formation of quadratic equation from their roots. They know it. Everything they know. They know the how when the real images are formed. This experience also they are well aware. Now your suggestion.
Okay, as we are not getting any response, I think they need some time to think on it.
Okay, then we shall discuss it again. Please
okay.
think over it.
Sir,
So-
just I wish to make a comment.
Yes.
The way we derived the equation from the simple length equation, 1 by v plus 1 by u equals to 1 by f, we can just substitute u by
Equal to
d
by
the distance,
yes. Simple.
by the distance capital D minus v.
Yes.
And we'll get a
Quadratic equation in V.
quadratic equation in V.
And you compared it with V minus V1 to V minus V2. You will
Yes,
get
sir.
the result. You will get the
Yes,
result.
sir. Yeah, I think it is possible.
Very simple.
Feasible.
Very simple.
Yes, sir.
That I telling that everybody, even in class 10 students, can know these things. Okay, and even at the class 10 level now, quadratic equation is also taught. So this question can be shared even before the class 10 standard students. Is it not?
Yes, sir. I think it is doable.
Yeah.
Thank you, sir.
Okay.
So
Now I think we are already 7
yeah.
to.
So, thank you everyone for being with us, and thanks Professor Samanto for sharing such ideas with us. And with this, now I'm going to end the session as it is already.
Just another problem I have in mind. I just 1 minute. I'm telling that you can suppose in an experiment with Ohm's law. Okay. Hello.
Yes, yes, sir.
Please hear. In an experiment with Ohm's law, I think everybody of us known the circuit arrangement of the Ohm's law experiment. So a student actually placed the voltmeter across the source. He measured the potential difference across the source and current, in fact, by mistake. Now, what would be the nature of the graph? This is my statement. In an Ohm's law experiment, mistakenly, a student put the voltmeter across the source, not across the resistance. And he took the data, ultimately draw a graph. But what would be the nature of that graph? Please think over it.
Sir, it should be the same.
Please, the same. But what quantity? Will he determine the value of resistance from that?
So we can get the current, and from
Yes, current. Everything is the same. He does not just somehow he has forgotten to connect the right way. He has connected the voltmeter across the source.
sir, we'll
You
get
know, the in Ohm's law experiment, source, the resistance to be measured, and the ammeter all and the source all are connected in series. Okay, but the voltmeter has to be placed across the resistance, but he has mistakenly placed it across the battery. That is the source. He took the data without taking anything in mind, and he draw the graph. What should be the what graph would you obtain?
sir, he must be the internal resistance of the battery.
That's correct. International of the battery. But and the graph he will obtain it with negative slope, and that slope, and it will not be passing through the origin. But that graph will yield a value of the internal resistance. Okay.
Yes, sir.
So thank you for participation. And I
Sir,
think
I have a question to Anirban, sir.
okay.
Yes, please.
Sir, on the the day after tomorrow, validation
Okay.
program, you see a program. So there will be an evening session, or in the morning session, it will be get over.
So, on 13th, there will be a single session in the morning, and that will be a common session. And on 14th, we'll do the valedictory.
Okay.
13 there will on both the days there will be no afternoon session. Is
Yeah.
it true?
Yes, yes.
Actually, he's asking that question.
Yes, that is I'm telling. On 13th, we will have the single session
But the
at
morning
morning.
session may be extended slightly if needed.
Yeah, that will depend on the nature of our discussion. So that may be some extended program, like we may, and that will depend on our topic and discussion. So we will have only one morning session on that day, and on 14th also there will be a single session as valedictory on morning. At morning, both the session will be there. So thank you again, and now I'm going to end the session. So thank you.
Thank you, sir.